Alright, so the right triangle, round decimals to the nearest tenth. And my triangle PQR. 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 Right triangle. This is P vertex, Q vertex, R vertex. More than that, you were told that one side is 4, another side is 6, and you have to solve the right triangle, which means what? You have to find what? You have to find the sides, which, you know, only one is missing, and then what else you have to find?
The angles?
The angles, right? So in this case, we're going to apply the basic trigonometric functions.
How would you find QR? Would it be QR equals 4 squared plus 6 squared? No, it would be 6 squared equal, yeah.
We're applying Pythagoras theorem, right, for this triangle.
It's the opposite of Pythagoras theorem.
The missing QR is one of the legs, right, which means PQ squared plus QR squared equals your hypotenuse, which is PR squared, right? Well, because we have to find QR, if you solve for QR, you subtract this PQ squared, which gets moved on the other side with a different sign. You have that your QR squared equals PR squared minus PQ squared, right? What I'm saying is move on the other side with a different sign. You're basically subtracting PQ squared from both sides. And PQ squared minus PQ squared on this left side will cancel each other, and you have left PR squared minus PQ squared. Do the substitution. PR is what? 6 squared minus PQ squared, which is 4 squared. You have 36 minus 16, which gives you 20. Now, how big is QR? Square root 20, which, if you want to simplify it, will be what? Square root 4 times square root 5, which is 2 square root 5. Alright, so I know my QR is 2 square root 5. Next, I have to find the angles, right? Well, one angle is known, right? That's PQR is my right angle, that's 90 degrees. Done. Which other angle would you like to start with by finding? Doesn't matter. Okay, let's start with this one. Angle QPR or angle P. Let's name it angle P. What trigonometric function can you or would you guys like to use here? Sine, cosine, tangent. I know this one, no, because this one is 2 square root 5, right? This is a right triangle. Sine is what? Sine of angle P is always the opposite over hypotenuse, right? In this case, the opposite is what? QR over hypotenuse PR. And if you plug in your values, you have QR 2 square root 5 over 6, right? You can simplify here by dividing top and bottom by 2. And you have square root 5 over 3. Now, are we done? Well, we're not done because we have to find angle, the measure of angle P, and we're going to use the inverse sine function for square root 5 over 3, right? So this will be inverse sine of square root 5 over 3. That will be the measure of angle P, actually, right? And using your scientific or graphing calculators, make sure it's set up for degrees, right? I got degrees, alright. And I have inverse sine, which if you have this graphing calculators is going to be second sine to the negative 1. If you have the scientific calculators, maybe also second and inverse sine. Let me see what is on this one. This one doesn't have it, so you need another type of calculator. Right, let's find it out. inverse sign of square root 5 of square root 5 inverse sign divided by 3. What did you guys get? Anybody? Nobody did it? Is it 48 degrees?
Sure.
Approximately 48 degrees. Now, you should always double check by finding what is sine of 48 degrees. Sine of 48 equals 0.74 approximately. Now, how do I know that that is, the same with the square root 5 over 3? Well, you're going to find what is square root 5 over 3. And it seems to be pretty close. So we're good. This is 48. So your angle P, the measure of angle P, is 48 degrees. What else are we missing here? We're missing angle R. How can we find angle R very quick without...
90 plus 48.
Absolutely. P and R are complementary, which means the measure of angle R will be 90 degrees minus the measure of angle P. And that equals 90 minus 48, right? Which is 42. And we are done. Triangle solved.